Good morning, students. My name is Chandan Ghosh, and welcome to my YouTube class, Mathematics. This is in continuation to what we have discussed in our previous class, that is on permutation and combination. Today, we'll be discussing some of the applications of fundamental principle of counting. Let's begin. So what we have learned in our previous class, fundamental principle of counting. So it could be principle of addition and principle of multiplications. Today we will be discussing some of examples where this principle of multiplications are being used. Uh, I was given five different numbers. Let's say one, two, three, four, and five. And I've been asked to arrange these five letters to form five letter word. So how many such arrangements I can make? Other way around, how many such five letter word can be formed with this five digit? One, two, three, four, five. Let's start with this. How we can solve this? So today we'll be introducing how this problem can be solved through a branching method, which is basically application or extension of principle of counting. It's a multiplication. So let's start with one. So I just wanted to know how many such five-digit number can be formed starting with one. So if the first position is one, the second position can be filled with four different remaining number. So what are those? 2, 3, 4, and 5. So let's say 2, 3, 4, and 5. Let me choose the second position as 4. So the third position can be filled with three different letter remaining, which are 2, 3, and 5. 2, 3, and 5. Let me choose the third position as 3. So fourth position can be filled with two different remaining letter 2 and 5. And if I choose the fourth position as 2, the fifth position can be filled with only one number, which is 5. Let me choose this part. This one. So the number uh, that can be formed 1, 4, 3, 2, and 5. This is one of the numbers. So how many such five-digit numbers can be formed with this five number? So likewise, this is one of the numbers. So let me explain this. So how many numbers can be formed starting with 1? So in the first position 1, the second position can be filled in four different ways. Let me write it here. Four different ways. Third position can be filled in three different ways. Fourth position can be filled in two different ways. Fifth position can be filled in one different way. So this is one of the path I have taken. Likewise, if I take a different path, so two, if I choose 2 as the second number, then third position can be filled similar three different ways. This. And the third position, this is also can be filled in two different ways, and this is one. So if we could remember the example that we have taken other day, let's say I am moving from place A to B via C. I'm moving from A to B via C. From A to B, I can travel three different ways, and from C to B, I can travel two different ways. So I can travel A to B via C in 3 times to 6 different ways. This is the fundamental principle of multiplications, correct? If we apply the same you know the the same multiplications, so how many different arrangements can be made? Other way around, how many five-lettered word can be formed starting with 1? It should be 4 times 3 times 2 times 1. That is starting with 1. Likewise, how many numbers should be there starting with 2? It would be the same, 4 times 3 times 2 times 1. And all the way till 5, it should be 4 times 3 times 2 times 1. So in total, how many 5-lettered word can be formed? It should be 5 times 4 times 3 times 2, which is nothing but factorial. So, uh, what is the takeaway? If I've been asked to arrange 5 letter or 5 number, I can arrange them in 5 different ways. Okay, now we'll be solving one interesting problem using fundamental principle of multiplication. What's the problem? Let's read through the problem. Find the 367th number from all the 6-digit numbers that can be formed using the digits 1, 2, 3, 4, 5, and 6 without the limitations. So we'll be finding the 367th number from all 6-digit numbers that can be formed with the digit all the way from 1 to 6. No repetitions are allowed. So we need to find 367th number from all 6-digit number that can be formed using this digit. So first of all, we need to find how many 6-digit number can be formed with 6 digit. So it should be 6 factorial. So which is nothing but 6 times 5 times 4, 3, 2, 1. So it should be 720. So let's begin with 1. So how many such number can, before that, let's find the minimum number. So what should be the minimum 6-digit number with this? So it's simple. It's 1, 2, 3, 4, 5, 6. And what should be the maximum number? This is the minimum number. What should be the maximum number? It should be 6, 5, 4, 3, 2, 1. And we need to find 367. Total 6-digit numbers, 720. So now we need to find how many 6-digit number can be formed starting with 1. So it would be definitely, if it starts with 1, it should be, you can divide this by 6, it could be 120. Or you can simply, if the first position is 1, so remaining 5 position can be filled in 5 factorial ways, which is nothing but 120. So we can form 120 such 6-digit numbers starting with 1. Likewise, with 2, we will have another 120 number, and 3 as well, 120. So we need to find 367. So it should be 360. So the 367th number definitely will start with 4. Let me so the number starting with 4, we need to find 4. So the 361st number should be 4, 1, 2, 3, 5, 6. This should be the 361st number. Yes, and we need to find 367. So let's say 4. So we need to find the number starting with 412. So how many numbers we can form with 412? So the remaining 3 place can be filled by 3 factorial ways. So the number starting with 412, we can have 6 such numbers. 3 into 2 into 1. So number starting with 412 will have 6 such numbers. So that's 360. Sixth number would be 4, 1, 2, 3. Sorry, the maximum number it would be 6, 5, 3. And we need to find 367. So the next number would be definitely 4, 1, 3, 2, 5, 6. So that would be the 367 number. Hope you understood. In case you need further assistance, you can write on the comment section. I'll respond to that. Thank you. Start another problem using counting principle of multiplication. Let's understand the problem first. In a multiple choice exam consisting of 20 questions, each question has 3 options A, B, C, and for each question a student can choose one of the 3 options, or he or she can leave the questions unanswered. So what we are looking for, how many different answer sheet can be created by the student. Let's approach this problem. So there are 20 questions and there are 3 options A, B, C, and you can leave. So I have kept another options. If you leave, let me name as D or L. L stands for you can leave. So how can you approach this problem? So let's say first question. Question number 1. Options are A, B, C, and L. L stands for leave. So you can choose any one of the 4. You can choose A, you can choose B or C, or if you don't choose any one of the 3, you can leave the questions. So there are 4 different ways to choose question number 1. 4 ways to choose question number 1. Similarly, question number 2, there are 4 options. See, you can choose any one of the 3, or you may leave. So there are another 4 ways of choosing question number 2. Now let's say you have chosen option A for question number 1. So how many different ways you can choose option question number 2? You can choose A, you can choose B, you can choose C, or you can leave. So for every single option chosen for question number 1, you can choose 4 different ways of question number 2. Now if we apply the counting principle of multiplication, how many ways we can choose question number 1 and question number 2? It's simple. 4 times 4, 16 different ways. If you need to answer 20 questions, so how many different answers it can be formed? It would be simple. 4 into 4 into 4, 20 times. It would be 4 power 20. Hope you understood this problem. Thank you. So let's solve uh, similar sort of questions. We will tweak the previous questions slightly. So what we had in our last questions, there are 20 questions, and you could choose one of the three options, or you can leave. Instead of that, if the question is like you can choose any combinations of the options. What does that mean? You can choose A, you can choose or B or C, or you can choose any combination A, B, B, C, or A, C, or A, B, C, all three. Additionally, you can leave the questions. So as many combinations you can choose. Then in that case, how many different answer set can be formed? So let us approach this. Uh, let us solve this particular problem. So what are the different combinations we can choose? Let's say question number 1. So I have this option A, B, C, or I can leave. What are the different combinations I can form with this? I can choose A, B, or C. I can choose AB, AC, or BC, or I can choose A, B, C, or I can leave. So how many options are there? I can choose A, 1, 2, 3, 4, 5, 6, 7, total 7 plus leave. One option. So there are 8 different ways I can choose question number 1. Similarly, question number 2 can be chosen 8 ways. 8 ways. So if you need to attend all 20 questions, so how many different answers it can be formed? It's simple, using the principle of multiplications. It should be 8 cross 8 20 times. So it's 8 for 20. So the same problem we can approach different way. How can you do that? Let's say question number 1. Options are A, B, C. What I can do, there are 2 choices. Either I can choose or I can leave. Tick for choose, cross for leave. Similarly, I can choose or leave. I can choose or leave. So how many ways I can select this question? There are 2 ways. Either I can choose or I can leave. Similarly, I can choose B in 2 ways, C in 2 ways. How many different ways I can choose question number 1? 2 times 2 times times 2 equals to 8. Now the question may arise, does this include the leave option? Definitely. So if you cross all 3, so which means you may leave the questions. So every single questions can be chosen or answered 8 different ways. There are 20 such questions. So the total number of answers sheet would be 8 or 20.